Hello. Finally Friday, yeah? And we are back on the amplifier. Now, before, yeah? Let's go on the last video and have a look on the comments. Because, the people don't always understand the thing. So, are two kinds of people. People coming and pressing dislike button. They will never find the... They will never understand, yeah? And the second type of people, they actually leave a comment. And when the people leave a comment, even if it's a negative comment, it's fine. I'm happy, because I know what's his problem, what he didn't understand. So I'm happy, even if it's a negative comment. Yeah. So always leave a comment, because I understand. It's not easy, and I can't. I know I miss a lot of things to explain when I'm doing something. But just the people they coming and pressing dislike is nothing to learn, and I don't know why. I don't know why did you press that button. That's the problem. Just leave a comment. I don't mind, just press dislike, but leave a comment so I can explain you on the next video. Okay? So it's fine. I don't mind. The negative comments are okay. It's constructive critics, yeah? So on the last video, short to ground, yeah, you are funny, man. Okay. Now, Mr. Technics Bull. This make my day. Here in my service, we have a word when we say all should be fine and work, but if you are not sure if it is, everything is power and wire. I understand that. Then you power it on and hear the click. Now everything is all wire. You know what? That will happen. Yeah. You pay attention on this video, okay? So if I'll use more current on my power supply on the moment when I reverse the voltage, yeah, the next step, you hear a click on the power supply and everything is wire, because that center diode will be a wire. That's how the center diode are working, yeah? But because I reverse the voltage, the center diode is a normal diode, and because I have a current limit and the current limit was low, yeah, you can check that video, nothing happened. Because many on the comments, they said, okay, now you killed the chip. You can't kill the chip, you have a diode. If you check the video, the voltage didn't rise because I have a diode and I'm using a low current limit. That's how I'm working. You are very safe on this way, yeah? So yeah, that was a good one. You kill, no, I didn't kill, you have a diode there. You have a diode and I have a current limit on my power supply. The voltage never rise. Yeah, it's not my one. Maybe transformer is telling you. No, it's not my one. Yeah, Mr. Chris, he understands the issue. He understands the problem. And what he's thinking, he's thinking that the center diode died and that burned the chip. Well, can be. You can be right. But think, at center diode, the way how it's working. So we know the center diode is fine. Because we reverse the voltage and it's there, it's present. He limit the, you have the click, okay. It's a diode there. But the center diode, the only way how the center diode get burned is shorted. And I don't have a short there. I seen that from the beginning. Was 0.7. If you have a shorted center diode, it will be 0 volts. Yeah? Well, thank you for your comment. You did understand the issue, and you predict how that happened. I'm not sure about that. After the chip removal, center diode must be tested. Yeah, you're right. So remove the chip and check the power rails to see if you have plus minus 15. Personally, I think center diode has destroyed during the last repair. How you can destroy the diode? I replace a relay on plus and minus 45. And chip temporary work. How can temporary work a chip when you have a Zener diode? That's how a Zener diode is working. When the voltage is rising over 45, over 15, the Zener diode will shut the voltage down. That's how a Zener diode is working. A Zener diode is like a dog. It's a beautiful electronic component. If you want to protect your device, just use a Zener diode. And the moment the voltage rise, it will limit. If the current is too strong, it will go shorted. Yes, you will short the voltage to ground. So there's no way. After a day, a chip got burned out. Okay, I don't think so. Shorten Zener diode and destroy chip. Reversing polarity doesn't forgive. Yes, it does, if you have a diode. Yeah? Check the video again. When I reverse the voltage, I have like 0 volts, 0 point something, probably on the voltmeter, on the power supply. You have a diode, Zener diode. If you reverse the voltage, it's working as a normal diode. Yeah. Suppose you limit the current 200 milliamps, the Zener is 15, that's 3 watts. Your Zener will likely be destroyed. If it was like a fraction of seconds, and the Zener diode hasn't been destroyed. You remember we came on that power rail. The power supply was not short. Actually, was nothing taking power. Yeah. The perfect solder is not soldered properly. I know that was a funny one. Zener took a big hit. Yeah, twice. Okay. It seems that your current was limited, approximately 750 milliamps, so it was fine. Too much for a Zener. Yeah, if it's a short time, the Zener will support even more current. The forward in voltage will drop to 1.2 volts. Okay. I should only get okay. Okay. I understand. Yeah, thank you. So desolder the chip. That's a good idea. I desolder the chip. I haven't checked. You cut my mistakes. Wait, that's the thing. I do mistakes. That's why I'm using a current limit. You understand? So we are fine. If you use a current limit, you are okay. Okay. No, the negative comments are you know, are constructive. I can answer on them because obviously there are people that didn't understand the video or they missed something or misunderstood. No, I didn't destroy the amp. You have a Zener diode. I explain you on the other. If you reverse the voltage, the Zener diode will be a simple diode, a normal diode. It's a common amp. Maybe it is. You know what? I did work with a lot of operational amplifiers on my time, but that one was 741. You remember 741? I work a lot. That's the problem. 80 milliamps is too much. You see other people figuring out the problem. Thank you. Thank you. A lot of positive comments. I know. I was thinking it's short, but actually it's not. It's not that easy. Amp dies. It's not because of me. I don't even know if that amp is dead. But we'll see. We'll see in this video. Nobody fault. Yeah, nobody fault, but I still have to fix it. The big caps, no, the big caps are fine. Replace the whole thing. by some kind of regulator to produce minus 15. Is no point. Something is taking too much power, and that's not the problem. On the output of that chip we have plus 13 volts. I will open my big transistor and will output voltage on the speaker, so it's no point. Better give money back. Why? This is different fault, different story. I guess it's the relay. How can be the relay? It's just a relay switching the main power rails. Waiting for the next part. I'm waiting as well, you know. I just wait to see if that chip is dead or not. It's you know, it's I just present you the other side of a problem. $1845 volts on the speaker indicates some major short. No, what do you mean major? You know what's the problem? On the operational amplifiers like this one, yeah, you have the input, you have what's the name? The straight and the reverse, yeah, plus and minus. If there you have a problem, all your amplifier, the whole amplifier will the output on the speaker can be moved to plus and minus. You can have like a small resistor, and that will mess up with your amplifier. You are injecting positive 15 to negative rail. Lol, I made mistakes too. Yeah, I'm due. That's why I'm using a current limit. So that current limit just saved that center diode. Yeah? Okay. Who does not have a hundreds 1 kilo ohm resistor just laying around? We have none. None. So all the components, you know, it's everything on the boards. We don't have components around. Everything is SMD on these days. And no, we are not fixing too many amplifiers, so to have this kind of big components. Use his voltmeter and now try to jump voltage to see what with the multimeter. It's no short there. What do you mean? What you can see from with the multimeter? There is no short. It's taking too much current. It was like, you remember, like 80 milliamps instead of 3 or 5 milliamps. It's nothing to check with the multimeter. This is an easy repair. Okay. Actually, it's quite a hard one. First time he repaired, he jumped the relay for some reason. No, I replaced the relay. That was the first video. I replaced the relay. I fixed the video on the relay on the video just to test the amplifier. And after that, I write there on the description, I did order and replace the relay. So actually the relay was was replaced. It's a brand new relay. Now he said the other board is not needed. You see that you speaking about the input board? Okay, I will explain you why. Yeah, let's go on paper because a lot of people they are confused here. Yeah, let's go on paper. I will take some time to explain exactly how this amplifier is working. Give me 1 second. Let's see. Let's make some space. Let's learn about amplifiers, yeah? So what do we have here? We have a transformer, yeah? With 2 outputs. Okay. That's ground, yeah? And this one is coming to a rectifier bridge. Let's jump this here, and it's coming to a rectifier bridge. This is a C plus minus, okay? Plus minus will have we have the two big caps here. Plus, and this is connected to ground, and we have minus, and actually this is connected to ground, yeah? Okay? Ground. And after that we have the relay, the faulty one, like that. That's our relay. And after that we have plus and minus. We have a power supply, this one, which is plus minus 12, which is fine, yeah? And we have this one with a problem. So our problem is, the power is like that. We have two 1 kilo ohms resistors. Obviously, we have plus and minus, yeah? Plus 45, minus 45. The first problem, from where we start like that. We have the big transistors of the amplifier. We have the output, yeah, the speaker here, and here connect to ground, the speaker, yeah. This is the middle of the big transistors. Here is minus. Actually are 2 and 2, yeah, are on the parallel mode. And after that we have the drivers of these transistors. Yeah, how it's connected is not important. And from this we have the base, okay? We have the base of these drivers. This on the middle you have the transistor with the base on the is regulating the idle current, yeah, idle current, keep in mind, yeah, the one which is connected on the heatsink, this one, you see. So this one is regulating the idle current based on the temperature of the heatsink. But now the funny part, yeah, from here we have the operational amplifiers. So the output of this one is going here. The problem is I have 45 plus 45 volts on the speaker. That's my issue. 45 volts. The only way to be here 45 is this to be open, yeah. What I did before on the first thing, I disconnect. You see, these are the drivers of these big transistors. I disconnect the bases, yeah, the base and the base. I desolder, and I have 0 volts on the output. That means my amplifier is fine, yeah. So I move here. I move on this one, and I found actually the minus 15 was missing. Yeah, you remember? So the power supply of this one is like that. We have the resistor. You have a channel to ground. Sorry, this is plus. Should be on this side. Then that's the plus of the diode. And here you have plus 15 is going to the plus of the amplifier, 15 volts, and that was fine. And the minus one, we have a resistor. From the resistor we have a channel to ground, and from this point we have minus. And here should be minus 15 volts. Yes, now you remember. Now let me remind you, maybe you didn't understand the video. What I'm saying was no easy one. So my minus 15 was like 0.7, you remember, 0.7 volts, okay? So what do we have? We found the solder on the resistor. So on the resistor on pin, I have like minus 45. Yeah, but on the solder was like 0.7. Okay, that was nothing. We soldered the resistor, yeah, and what we seen? Same problem, 0.7 volts, minus 0.7. So I think, you know what, if here I have minus 0.7, can be only two things, yeah? One, something is drawing too much power, or two, my resistor is burned actually, yeah? So I took out the resistor. Keep in mind, you can check the resistor is fine, but actually he has a the resistor can be burned and actually it's not driving the current. So I replaced the resistor and I got same thing, 0.7 volts. So what I did next? The next what I did, I come with the power supply, yeah, and I check to see if it's taking any current. What current was taking? Huh? Zero. So you see, a case like that will drive you crazy. So nothing is drawing the power. Nothing was zero. Was absolutely zero current on the power supply. But here it has a 0.7. This will drive you crazy, you know, because you don't understand. I didn't understand, but what catch my attention was on the fact when I was switching off the power supply. If you check the video, when I was switching off the power supply, the voltage get rising here around -3, -4 volts. Did you see that? And when I seen that, I understand can be is drawing power only when the amplifier it's off. Yeah. So when you power off the amplifier, here start being like -3, -4, jumping from 0.7. I say, you know what? Here is dodgy. So this thing, what is on this power rail, is taking too much current only when the amplifier it's on. But when it was off, this power rail goes up. And I did check with the power supply with the amplifier on, and was taking like 80 milliamps. So don't understand the things wrong when the amplifier is off. Actually switching off, you still have current on capacitor. You have two big capacitors, they will keep the current nearly 1 minute. Yeah. So even now I don't fully understand exactly what's the problem. Because my problem is the output of this chip is 13 volts, which is maximal output of this chip. Yeah. Let me check. Let me find the chip data sheet. 1 second. 55. No, 4558. 4558. Yes, that's the one. That's the one. So check here. That's an operational amplifier, okay? Now, if you were before, yeah, look, max output swing, like typical 13 volts, exactly what I have there, plus 14, okay? Sorry, I haven't switched. Now, the reason, just to answer to that gentleman, why I removed the first part, because the operational amplifiers, you have, what's the name? What's the name? What's the name on the pins, of plus and minus? Yes, inverting output and not non-inverting input, non-inverting input and inverting input. And you have two pins here, plus and minus. Yeah. Now listen, if you play on these pins, if you have a fault here, this output can go from -15 to +15. So actually you can have a fault here. It's not necessary this to be burned. This was one of the reasons why I removed the input part. The input meaning this board. Yeah, this board. I remove it and I short the relay. Okay, that's the reason. Because anything wrong here, you'll have voltage on the output, on the speaker. You understand? So you see, it's a funny case. Even now, I'm not sure if I'll replace the chip. It will work. Should work. But who knows? Should work. Because there's nothing else what... Actually, it is. Okay, let's replace the chip. It's... Yeah, I know. Let's replace the chip. We have a brand new chip. Oh, let me get the diodes. Let me replace the center diode. The center diode it actually was good, was no problem. But I took the center diode out and I lost it. Yeah, so the center diode from there was fine. So 1 second, because I don't have a 15 volts one, so we have a 13 volts. And no, that's too much. Okay, I will use not this. I'm using serial mode to diodes. And obviously we will check the power rail before soldering the chip back. It was a tricky repair, you know, that's the reason why we spent so much time on this. So again, yeah, with amplifier on, yeah, 0.7. When I check with the power supply, nothing was taking power on this power rail, nothing, 0. That's why it's tricky, because you think, okay, nothing is drawing my power, so why I don't have there the voltage? I know. You see, that's a tricky repair. Seems to be easy, but look, if it's easy, you know, just tell me what is the problem. Yeah, just tell me what do you think is the problem. If you think it's easy, just I can't learn anything if you don't tell me exactly. But look, I figured it out, and based on this and this, that's the problem. Okay? And I can learn something. Okay, the diodes are inside. Good. Let's solder the diodes. And after that we can check for to see if our power rail are good. So the diodes are soldered. We need amplifier now without the chip. Our resistor is still here. We can move it after. Let me get a power cable. So I have a check, I don't know nothing. On. Okay, let's check with the multimeter. Ground. Okay, I'll power it up, but it looks like from now it's voltage there, yeah? I'll power it up. Yeah, 16. And on the other one, that should be fine anyway, but we can check. 15. 16 with 15. Must be fine. Yeah, must be fine. Let's replace the chip. Let me get the chip. I know it must be here somewhere. Okay, where are the new chips? Oh, yeah. So we'll solder together the new chip. So even now, if we have something wrong on the inverting and not non-inverting input, it will be same story. Or maybe not. Maybe not, because it's not supposed to short my my minus 15. Yeah, so I believe the chip is dead. It's burned. We'll see now. So we have a brand new chip there. Seems to be fine. Let's get the multimeter and see what we have on the power rail. Okay, let's power on. We have 0.9 volts. You see exactly what I told you. This is how this is even possible. One more time. 0.9 volts. And on the plus, we do have 15. So we replace the chip for nothing. That's easy. Who said it's easy? Repair. Now, so why the chip is taking so much power? Easy. The first, we have no schematics. So cannot be easy from the beginning. The problem is this is a brand new chip. There is no reason to take so much power. It's supposed to take 3, 4, 5, max 5 milliamps. This is taking like 80. Same like the last time. And I said, you know what? Probably the chip is dead. So from some reason, this is the output. We have these two transistors. For some reason, these transistors are open on this chip. Wow. I'm dead. What this is doing here? This MOSFET is shorting the plus. No, it's not shorting because the diode is on this way. No. Okay. Probably this is for reverse voltage, maybe. Protection. Oh no. And look, even on this one it's saying each half electrical similarly to a 741. I work a lot of this operational amplifier. But this is a weird case. This is like it's shorting my minus. It's taking too much power on the minus. It's not only the output. We have like max voltage plus 13. It's not only about that. So I don't even understand how this is possible. It's over my understanding capacity. What can be wrong there to take so much power? Can be related with the input. Let's check. Let's connect the input board. Probably not. Probably not. I don't see how. No way, 0.9. The only difference, we don't have 0.7, we have 0.9. Wow. Okay, what did I found yesterday when I checked again the board? Actually, this track is going somewhere else. It's going somewhere else, but without the chip, we have the voltage. That's the problem. Without the chip, we have plus minus 15. It can be something with the inverting or non-inverting input. What is the schematic? Okay, can be something else. Yeah, can be. Yeah, this is just an idea because you know it's. I explain you. Yeah, in this moment I have no idea, but just a idea just came now on my head. Yeah, let's say if on my output is coming this 13 volts from something else. Yeah, you understand? So it's coming inside 13 volts. That can explain. That can explain this fault. So let me disconnect the output. I will desolder the output of this chip, and we'll check again. Yeah. So the output on which pin is? Which pin is the output? Because we have two outputs here. Output 1, pin number 1. Pin number 1 is used. Let me check. Pin number 1, yes, it is used. No, it is used. It's used for let me find for what it's used. Give me 1 second. Because also this amplifier has a switch on the back. It can rotate the signal 180 degrees. So pin number 1, it is used. Okay, and pin number, because there are two operational amplifier inside of this chip. Pin number 7 is the second output. Number 7 is here, and that's what the output what I checked, the number 7, which is going here, and is going to the amplifier. So I'll disorder that two pins. Yeah, I think that can be only the explanation. So actually the output of this chip, that 13 volts, is not from this chip, it's coming from the different place. There. Easy. Who said it's easy? Yeah, all this all are the both inputs. The both outputs, sorry. And pin number 7 is this. Okay, so the both pins are soldered. So in this place, so on this moment, yeah, if I start the amplifier and I have -15 there or -16, it means the problem is like how I said, yeah. Let me grab the power supply. Minus. I'll switch on the amplifier. 16, -16, check on the multimeter, -16. So my voltage is coming, let me see from what. It's coming from here, it's coming 19 volts, plus 19. So plus 19 on this output. Let me see on this one. And this one is nothing coming. So you see, you understand? My problem is the voltage. My voltage is not going out from this chip, it's coming from this somewhere here, it's coming here inside, and it's shorting my minus 16, minus 15 volts, yeah? Now it's simple, because here, what do we have here? What do we have here? That's the track, yeah? That's the track. We have here a few components, probably not important. We have a diode. Let me see, let me switch the multimeter. Diode. So here we have a diode, and the diode is fine. What do we have more on this output? It's coming here. Here we have a jumper, I think. Yeah, we have a jumper and a resistor. So I'll pay attention on the jumper, not on the resistor. This is 2.7 kilo ohms. So that cannot kill my negative power rail. So the jumper is coming here. The jumper is coming here on exactly, I think, the emitter of the idle transistor. Let me check with the multimeter. So from here to the chip is 0, 0. So it is coming here, yeah? This one is burn or what? No, this one is fine. But that's not important. Even if it's burned, I will have less idle current. It doesn't explain. What do we have here more? Here we have a jumper, and the jumper is going straight. Here we have a jumper to this pin of this driver. Wow. So the base is coming straight on the base. On the base we have this resistor which is not burned. I don't think you can see. But this resistor is not burned. This is fine, 22 ohms. It's coming here. No, I think I'm wrong. Coming here, here. So it's coming on this pin. This is a meter. Yeah. I think that's a meter. No, it's not a meter. No, depends. Let's see. Let's see what is there. Let's check this one. Yeah. Okay, so this is base. What? So on this side and on this side. So see, this one is burned, but it's not shorted like how you expect. It has a resistance between probably base. I think it's base here, base and collector. So here it's driving the power. Twisting the multimeter probes, it's driving, you see, on the multimeter. With this pin, It's not doing anything. With this, look, this is clear shorted. Here and here. So I don't know, depends on what transistor is. We can, I don't know if this is the base or the opposite one is the base. No, if it's coming, no, this is the base. No, it's not even point checking. But I want to check, maybe it's Darlington. Can be a Darlington transistor. Just to know what we replace, yeah? So this one is 669A. 6. Keyboard is not working. 669A. And it's starting with H. Transistor. Two SD 669. That's the one. Huh? Can be. What's this? This is a normal transistor, yeah? Low frequency power amplifier. Pair with bipolar power gen. This is a normal one, NPN silicon transistor. So it's nothing special on this one. Yeah? It's not Darlington. Okay, collector emitter 120 volts. And the A one is 160 volts. Yeah, Houston, we have a problem here. Okay, let's find a transistor. Where we can find a transistor? I have at home. It's an NPN one. Yeah, and now someone will say, oh, why you don't have 100 around you? We don't. We have boards, and we have laptop boards. 99% of the boards are laptop boards, and 1% are TV boards. You can't even find, even on TV boards, for what you'll use that transistor. You have to take one from one amplifier. And that's a MOSFET. Don't tell me I have to do another part of this video. This is a transistor or a double diode? Can be a transistor. Yeah, no, has to be pair. Yeah, this has to be a pair, like on ideal situation. Should be a pair. The same things, the same amplification factor. Maybe this is a MOSFET. But let me check. Let me check. M B R F 1015 10 15. What's this? It's a double diode. Okay, I think we have to stop. What? Come on, man. I found the audio board. I can't believe. So I found the audio board. This is a audio board. We have a transistor here. This is a board from an audio amplifier. Look, the double resistor. C329. 1 second. Please be NPN. C329. What's here? 8. Oh, that doesn't sound good. It's a NPN. It's a NPN transistor. It's a NPN, 200 volts. The collector, yeah, this is even better. 1.5 amps, the same like with the other. This is even better. Okay, now we are a bit on a problem. How the base is there? Wait, what? This one, I think the base is here. Well, I will check. H6. Yeah. Come on, what is saying? It's not saying. Okay, pin segment. Assignment, sorry. So pin 1 is the base. Yeah. Yeah, come on, man. We have the schematics here. What do you mean? No. This is the base. Let's take this out. So on this one, the base is here. Okay, that's the transistor. And the base on this one is there. Let's check with the multimeter. Base. Yeah, that's the base. Collector emitter is good, but that's the base. But if I pull like that, the base is here and it's not normal. I don't think the base is there. The base is exactly... The base on this one should be here. And it is here. Yes. So that's the base, but on my one, the base is on the other side. So what I will do, oh, this is too big, I can't even use this here. Okay, just let's for testing, and I'll order the transistor. So I'll put the transistor on the other side, so not like that, should be like that. Yeah. Good. Let's check. I'll solder back the pins of the amplifier. That's interesting, because on the beginning, before start working, I unsoldered the base of this transistor, was no output. So, yeah, that was a tricky one. Okay, let's check together. Maybe we'll blow up. Let me connect the ground. And on the minus power rail, yeah, now it's working. Let me power on. I can't reach the power button. And now we have minus 16, you can see. So what do you think? It's working. Yeah, I solder back the pins from the operational amplifier. Let me actually, no, I have here this. I will unsolder the relay. You remember we short the relay? Now it's not shorted anymore. Let's connect the power. Let me connect the speaker so we can test. We'll be fine without the heatsink. We'll be fine. It's just for testing. Okay, it is fine. Let me power on. Yeah, it's working. What is the volume? Line in. Yeah, are all cold. Everything is cold. Maybe you can't hear the sound. Yeah. I'll put my microphone there. So how they sound to you? They're cold. So what do we think about this? We should put back the original chip. Yeah, let's do it. Let's put the original chip back. People said I killed the chip. I'm sure the chip is fine. Now will not be another part of this video, but what I will do, I will order the transistor, I will order a 15 volts Zener diode, yeah, and after that I will put all back together. Well, yeah, that was a tricky one. That was a tricky one. When the problem which I got it wrong is I did check these transistors. So I desoldered the base and there was no output on the speaker. There was no output. That's how I checked the amplifier. Because obviously if you start desolder each transistor, because you can't check them on the circuit, you have to desolder and check each transistor, that will be a bit long. So it was more easy to desolder only the base and check if I still have any output. It was fine. That's why I moved here. So I moved on this part, on the input part with the operational amplifier, and what I found a missing power rail, and I said, okay, I'm fine. My fault is from here. No, this wasn't an easy one. It's quite a tricky one. Look how much time we spent. First video and now, and it's not finished. I have to order more things. This is the original chip, yeah? This is what was here before. So we'll use this one. Let me straight the pins, yeah? The chip is inside. The position is okay. The chip is soldered. One more time. I don't know if you can hear. I can leave it on, but you know, are cold, but you never know. It's working fine, okay? So I'll stop this video. This is the end of story. Well, look, I have here one more. I'll stop this video. I'll order another Zener diode and another transistor, and the amplifier is fixed. No, was no other easy way. What easy way? Just checking random things? So what easy way? It's no other easy way. Okay. So the chip is okay, is good. The chip survive. Well, it's a long job, but we found a problem. It's kind of awkward, you know, because anyone who will open an amplifier, what will check first? If you have power on the speakers, yeah? Because okay, so I have plus 45 on the speaker. So what you will check? This and this, yeah? But I did check. I told you the way how I check this. Yeah, instead of desolder on these things, I desoldered the base and this base, and it was zero on the output. There was no output, and I said, you know what? Everything is good, so it's not even point checking here. Anyway, thank you for watching. Like and subscribe if you like the video. I know it's a long one. If you want to dislike it, but just leave a comment and explain me what you didn't understand. Yeah? I appreciate any comment. Good, bad, it's okay. It's fine. We can learn, yeah? So see you later. Not really. Probably next week. Yeah. Bye.